Dear students, my name is Makovkin Sergey Yuryevich. I'm your assistant professor and I'm your lecturer of the course of high mathematics. This is our video of the first practice lesson. The first topics it is a matrix and the methodics of calculation determinants of the matrices. So the practical tasks. No, I know that about students on distant learning, but for all students it is would be very useful. So, calculating determinants of the matrix. The first example, the matrix of the size 2 by 2 with the elements of in first line -1, 4, 3, -2. The calculation of the determinants of the this matrix size by 2 by 2, we need to calculate the multiplicating products with the positive sum value of the main diagonal minus the multiplicating elements minus on the not main diagonal. So we need to calculate -1 by -2. I see this mistake in the first example. -3 by 4, and so we get some value. No, this is a mistake. I need to multiply by -2 value. The second example, matrix is we need to calculate again determinant a plus b, a minus b, a minus b, a plus b. We need to a plus b multiply a plus b on the main diagonal minus the values on the not main diagonal a minus b, a minus b. So in square we are opening the bracket, first bracket and the second bracket. Some elements would destroy it and we get the 4ab. Third example, sinus a alpha cosinus alpha minus cosinus alpha sinus alpha. So sinus alpha by sinus alpha minus cosinus alpha multiplicate minus cosinus alpha, we get plus cosinus alpha, and sinus n square plus cosinus n square, we get the main trigonometric expression. No, of course it is equal 1. The determinant of the matrix 3 by 3. In lecture, you can see that we can calculate it in different ways. So the first way is to calculate the main diagonal 2 by 3 by 2 plus the elements on the triangles one side of this parallel by the main diagonal -1 multiplicate 1, we get -1, plus another triangle, multiplicating elements of the triangle 0, 2, and 3, we get 0, and we need to calculate another 3 multiplicating products staying on the not main diagonal, -1 by 3 by 3, -9, minus 2 triangles 0, -1, 2, we get 0, -1 by 2 by 2, -4, and we get some number. The answer here is -2. The example number 5, another methodic of calculating determinant, as you see in lecture. Here we calculate the determinant expanding by the first row, for example. So we write a value 2 multiplicate -1 in the power of first row plus first line in the power of 1 plus 1. No, of course, -1 in the power of 2, it would be +1. And we need to find a cofactor. We deleting first column and the first row, and the cofactor would be this determinants by matrix 2 by 2, 0, 2, minus 2, 2, then plus, we expanding by first row, value 3. Second line, first row, multiplicate minus 1 in the power of second line plus the first row, and the cofactor. We deleting first line and the elements on the first column, the second line. The staying elements minus 1, 1, minus 2, 2. Then plus the element of 4, they staying on the first column, third row, or third line. Multiply minus 1 in the power of third line, first column. We deleting, finding the cofactor, deleting elements on the first column, third row, line. The staying elements minus 1, 1, 0, 2. Then they calculating these three determinants and they calculating the results. Here the answer, the determinant of this matrix would be equal 0. No, it is some characteristic number of these matrices. Another example, number 6. Determinants of the matrix 3 by 3, minus 1, minus a, minus 1, and so on. We calculate this by the first way, 1 by 1 by 1, then minus 1 minus a 1, plus a by minus 1, minus the not main diagonal 1 by minus 1, all with the sign of minus, minus a by 1, and minus a by 1. Some elements are destroyed and we get the answer 2 and the brackets 1 minus a square. The application of the finding the determinants, it is the finding the solution of the example of the system of equation, n equation and n unknown values by Cramer's method. For example, we have a system of equation 2x plus 3y equal 1, and the second equation minus x plus 2y equal 3. We need to calculate the main determinant of the system. It is the values, it is a scalar number before the x and y in this system. So we get the number 2 and 3, minus 1 and 2. We calculate the main determinant. Then we need to calculate the determinant of the x for the x value. We change the number values before the x's to the values from the right column. So we change 2 and minus 1 for the 8 and 3. And we calculate the determinant for the x, get some value. Then we need to calculate the determinant for the second unknown element y. We change values in these matrices before y for the right column values. So 2 and minus 1 on the first column staying on their places, and for y determinants 3 and 2 we change for the right column values 8 and 3, and we calculate the determinant. To find the x, we need to divide determinant of x matrices to the main determinant. So we get here 7 divided by 7 equal 1, and for y, determinant of the y divided by the main determinant, it would be equal to. Another example, 1x plus 4y equal 12, 3x minus 2y equal minus 6. We calculate the main determinant, the values before x 1 and 4 in the first line, and second line 3 and minus 2. Calculate the determinant. Determinant of x, we change 1 and 3 in the first column to the right column values 12 and minus 6. Calculate it. Determinant of x here would be equal 0. It's not a problem because x would be 0 divided by 4. It would be equal 0. It's normal answer for x. And for y, the same way, it would be minus 42. And the y, it is determinant y divided by main determinant, equals 3. Another cases, special cases. For example, this equation, some exceptional cases. 1x minus 3y equal 2, 2x minus 6y equal 1. We calculate the main determinant of the value 1 minus 3, 2 minus 6. The determinant, main determinant equals 0. Determinant for x will be equal minus 9. It will not 0. Determinant for y will be equal 3. The main question how to calculate x, because for x we need to determinant for x divided by 0, and the determinant for y with 3 divided by 0. We cannot divide by 0, and we cannot answer the solution, so this way the right answer, no solution. Another way is to calculate this example. Minus 1x plus 2y equal 1. 2x minus 4y equal minus 2. Here we get main determinant equals 0. Determinant for x will be equal 0. Determinant for equal will be equal 0. For finding the x, we need to divide 0 by 0. It is uncertainless. And for finding y, we need to again divided 0 by 0. This uncertainness, and in this way we need to say that it would be an infinity number of the solutions. So Cramer, method of Cramer can check two exception solution, where in the system of equation we can get no solution or an infinity number of solutions. Another way is the system of equation 3 by 3, 3 equation and 3 unknown values, x, y, and z. Now again, we need to calculate main determinant. We need to calculate determinant of x, of y, and then z. And the same way, we here calculate and find some values. And here I checked the global answer. I put the finding x value in the system, y put in the system, z again in the system, and I see that 2 equal 2, 2 equal 2, 8 equal 8. No, I see that finding my solution is correct. Sorry. Second example again. Example of 3 equation, 3 unknown values. The same way I calculate it and I check the right answer. So this is the answers. I see that it is the correct answer. Then, students, I write you a homework, and the next practice lesson I start with checking your homework. You need to do this homework. No, for the first task, find the determinants of square root of a1 square root. I see the answer. Then, the second example, the third, the fourth. The task here, find x. You need to find the determinants and solve the quadratic equation and find the 2x, x1 and x2. And 1, 2, 3, 4, 4 systems you need to solve by Cramer's methodic and solve it and show me the answer. So this is the end of our first practice lesson. Thank you for attention and luck for you. Thank you.